Hello, everyone. We're going to go here, take a few minutes and do a quick lab on concave lenses just to see some of the properties as we move things around sort of in a live fashion. So let's go ahead and go to physics. Again, there's the site, PHET, phet.colorado.edu. And here's the physics. We scroll down to geometric optics right here. Not the basics, just go to geometric optics. And let's click on this. And we're going to do mirrors this time. So click on mirrors. And now let's pick our favorite object, which is an arrow. And we're using a concave mirror right there. Okay, and let's look at the principal rays. And again, they take this ray that goes to the vertex and bounces off at an equal angle. It's easy to do in a computer program, but it's hard to do it when you're drawing it. You know, so this is the focal length. They do not put the radius with the center of the circle here. Otherwise, we'll draw a line from it like we did in the previous couple of videos. But let's just see what happens. So here's an object far away from a concave lens. Let's make it just bigger. So I'm a concave mirror. Okay. And as you can see, I'm moving the object in towards the mirror. And again, you can try this. You know, again, usually any store usually would sell these mirrors, or in a hotel room, the bathroom, they have these mirrors. Objects that are far away from the mirror will appear smaller and inverted. And as we move in, they start growing in size, but they stay inverted. Okay, we're still moving in. Now they're getting bigger and bigger, and they appear to be farther away from the mirror as the object moves in closer. And then when we hit the focal point, similar to lenses, we get a whitewash. We see everything white because we are at the focal point and all the rays are going to infinity. No rays converge on either side of the mirror. And now we start to move in inside the focal point. And as you can see, let's make this smaller. There is the image. There's the object. And as I move it in, the image is magnified. It's upright. And this is what you really want from a mirror when you put your face close to it. And look at it. This is what I mentioned at the end of video number 3 in this series about the distance from the object to the mirror and the distance between the mirror to the image. Distance between mirror to image is always larger than distance between object to the mirror, absolute value, okay? Otherwise, we'll get a contradiction for the focal length, which will turn out to be negative math-wise, and that is not correct, okay? That's a converging lens. And as we move it closer, the object comes in closer. It's still magnified. I mean, the image comes in closer, but it's still farther away from the mirror than the object. Now, when we take it back out again, you'll see it gets bigger and bigger and bigger as we approach the focal length. Then when we hit the focal length, we get the whitewash that I mentioned. And then as we move away, the image starts, again, coming in bigger from infinity. Inverted, real, because the light focuses on it. The light goes through it. And as we move away from the mirror, the image comes closer to the focal point, and it becomes smaller and smaller and smaller. It never gets to the focal point. Okay, so this is what we got from just looking at this, and this is a very good way to just get a conceptual feel for image, lens, focal point, object, okay? By moving things around and saying, okay, this is how this will happen if I move it closer to the focal point, away from the focal point, inside the focal point, that kind of stuff. All right? So play with this, and hopefully this will make your physics more intuitive. All right, thanks.